Okay, so absolute value, what is absolute value? It's the magnitude of a number. Or in other words, the distance the number is from 0. So absolute value of a number is never negative. Negative tells you a direction. Okay, so for example, absolute value of -3 is +3. If we plotted -3 on a number line, how far is it from 0? 3 units. Okay, if I gave you absolute value of 3, it's also 3. Because if I plot that on the number line, this is 3 units. So there's 2 possible expressions that give you the same answer with absolute value. So essentially what you're doing, if the expression inside the inside the absolute value signs is a negative, you're really multiplying this by -1 to make it positive. You're changing the sign. If this is positive, it's staying positive. So that's going to help us when we're thinking about solutions to equations with absolute value, when we're looking at graphs of absolute value functions. Okay, so if the inside is negative, to take the absolute value, you change the sign. If you have a calculator, there's absolute value in it. If you have a newer version, this is an older version calculator, but go to math, go to num, and the very first one, ABS. Work in your abs when you're taking absolute value. So, newer versions of the calculator actually show the vertical lines because there's more height in your actual line and there. In this case, older versions, it says ABS, -3, close the brackets, enter. Okay? So it doesn't matter which version. You can still do it. Okay? When you're writing it by hand, make sure those absolute value signs are a little bigger than your numbers, so it doesn't look like a 1. So this goes higher than the 3 that I wrote. If I had a 1 in there, it would be the same height as the 3. So just make sure the vertical lines going higher than that. Okay, so let's just evaluate a few absolute value expressions. Okay. So you follow the order of operations. The absolute value is like a big bracket. So you have to evaluate inside the big brackets first. So here you have to evaluate inside the absolute value signs first. Then once you do that, simplify within there, then it's kind of like the order of exponents. There aren't any exponents, so you take the absolute value to get rid of those absolute value signs. So you simplify within the absolute value signs. Now you take the absolute value. So that will be +3. This is outside of any absolute value sign, so you copy it out. And then absolute value of -7 is +7. So you can get a negative answer to a question has absolute values? Because that has more than one. You're doing operations. But each individual absolute value term will always be positive. This is the term, right? This ends up being positive 7. We're subtracting it, but that actual value of 7 comes from here. Okay, this value of 3 comes from this. This one, order of operations. Again, you have to do inside the absolute value. There's order of operations. There's multiplying here, so that'll be 5 minus 16. Still have to finish inside there. 5 minus 16 is negative 11. Still have to take now the absolute value of negative 11, which is positive 11, and then multiply through. So again, we got a negative answer. We had absolute values, but it depends on here. We have multiplied the absolute value by a negative, so we end up with a negative. Bad notation is to keep the absolute value signs once you've taken it. So sometimes students will get to this point, then they'll write down negative 3 absolute value of 11, and so they'll get the correct answer. But once you've taken the absolute value, it's just equal to 11. Although it still works like this is bad form. Okay, so just be careful. Once you do that, just like once you take a square root, the square root sign goes away. Once you square a number, the square goes away. Once you take the absolute value signs go away. Okay? So that's just evaluating absolute value expressions. So now take a look in your note sheet. So get your note sheet out. We're going to do the first few together. This is the absolute value of a function. Okay. So we did this for rationals. We were graphed graphed any function, and then if we were asked to take the reciprocal of it, we took every original y value and we took the reciprocal. Remember how we found asymptotes and horizontal and vertical, that kind of thing? Now instead of that, we're taking the absolute value. So it says complete the table for the functions. This one's already done for you. Okay. Then take the absolute, get the y value if we're taking the absolute value of this. So that means that any negative will become positive, and 0 or any positive stays the same. Then it asks you to graph the original and the absolute value function. The original, that's in slope y-intercept 4. Do you even need a table of values? No, because we know the y-intercept is negative 6 and the slope is 2. So up 2 to the right one, up 2 to the right one. We can fill in, with a bunch of points. And then we can turn it up. Okay, so that's your y equals 2x minus 6. Now, if we are taking absolute value, we've got our y values there. So I'll do that in red, let's say. So when x is 0, y is 6. When x is 1, y is 4. When x is 2, y is 2. 3, 0, 4, 2, 5, 4, and 6, 6. Okay? Joining those up looks like a V. Just going to fix that a little bit. And I'll do this in red. So start and end. Okay, and we'll do this. Okay, so the red is your absolute value function. So what's happened here? These points here are not changing at all. So when our original y value was greater than or equal to 0, greater than or equal to 0. Greater than or equal to 0. Okay. These didn't change. These are exactly the same. For what x values does that happen for? 3, 4, 5, 6, and everything in between. Okay. So when the original had y values that were positive, when we take the absolute value, they don't change, because the absolute value of a positive is a positive. When in your original function the y values were negative, they changed. We had to reflect them in the x-axis because they changed signs. So this negative 2 became positive 2. This negative 4 became positive 4. Negative 6 became positive 6. So anytime you're given a graph and asked to graph the absolute value of the function, all the parts that are on the x-axis or above don't change. Anything that's below gets reflected in the x-axis. So you don't have to find a table of values. You can just strictly look at what's the y value here, now it becomes positive. What's the y value here, now it becomes positive. Anything that was positive stays there. If your expression in the absolute value signs is linear, that means degree 1, that means the exponent on x is 1, then it will have a V shape like this. Kind of like a parabola, but a V rather than a U. So it has some similar properties to a parabola. It has a minimum or a vertex, axis of symmetry, okay, equal distance apart. Domain and range, same thing, but it's straight lines, if that's linear there, okay? So we've done that part. Now for a quadratic inside, again, we've given you some values there. For x, we've given you the corresponding y. Now if you're graphing the absolute value of this function, anything that was positive to start stays positive. Same with 0. If it was negative, it becomes positive. If it was 0 or greater, it stays. Okay, so these ones stayed the same, and these ones stayed the same. Okay, it says use the table of values to sketch the original graph and the absolute value. So the original, this here, we have a table of values. Alternatively, you could factor it and then graph it. You could put it in completed square form and then graph it. But we have a table of values, so let's use it. -1, 12, 0, 5, 1, 0, 2, -3, 3, -4, 4, -3, 5, 0, 6, 5, 7, 12. Okay, so it's a problem. Okay. Absolute value, we can plot what those are, or think about what we just learned. Anything that is has got a positive y value on the original, stays the same. So my new graph is going to be, have that, and this. So these arms don't change. Okay, but these have to flip up. So -4 here becomes +4. -3 becomes +3. -3 becomes +3. And every other point in between. So then this looks like that. So it kind of looks like a kind of a weird W. Okay. I didn't have to look at my table of values, but you could have. But anything above stays, this reflects up. So remember when we were dealing with reciprocal, or the reciprocal of a function, we talked about invariant points. Points that don't change when you take the reciprocal of a function. There were only points that do change were when y is 1 and y is -1. Here, there's many points that don't change. Anything that has any x values that had a y value greater than or equal to 0 doesn't change. So all of these are invariant. All of these are invariant. Okay, so invariant points would be for x greater than or equal to 5 and x less than or equal to 1. Okay? We actually can't list all the points, right? So we would just say what for what x values. If you want to graph that in your calculator to check, then go to y equals and go math, num, absolute value, x squared minus 6x plus 5, close the bracket. I'll do a standard screen. Okay, and you can kind of see that funny looking W. Okay, that's the absolute value. Okay. So, to summarize, the graph of y equals absolute value of f of x is the same as the graph of the original, except the portions of the graph of the original that are below the x-axis are reflected in the x-axis. Points on or above the x-axis are said to be invariant points. They don't change. That's what I just talked about. Okay. So let's do these ones here in question 3, and then we'll call it a day. So these graphs are already given. You don't have to find a table of values. You don't have to come up with the equation. You have to sketch the graph of the absolute value of them. So that means here that you want to look at where the graph is above the x-axis, and those don't change. So I'm going to actually do a line here. So from here to here, that doesn't change. Let's fix that up a little bit, and I'll do it in blue. Okay. Then these ones, the y values are below, so I do change that. So in this case, you can choose a few nice values if you want. So this would be -2 becomes +2. Up here, so -2 becomes +2. Here's another nice one, -4 becomes +4. -6 becomes +6. and then join those up. Okay, that's your absolute value function. Next one's a parabola opening down. So anything above the x-axis, remember, stays the same. So the x-intercepts stay the same, and this, the part that includes the vertex, it stays the same. Okay? Anything below does not stay the same, it reflects. You want to try to make it as accurate as possible. So here, there aren't that many points that cross at a grid crossing, but for sure do those ones. So when x is -5, y is -6, so now that's going to be +6. And same on the other side. Okay, it's going to still be symmetrical. And then choose some other values, like here, for this particular x value, y is -2. So just make sure for that same x value, you're going to +2. Here, for that same x value, you're going to +2. Okay? And so that's pretty close. So notice, so the curve you need to be careful of. So this is going down and to the right, curve this way. So this is going to be curved up. So just slightly curved up. Because it is a reflection of a parabola. So parabolas go like this. Okay, rounded. It's not going to go like this. Okay. Think about folding your paper, right? If you fold this paper along here, it has to have the same shape as that. So then this one is going to do the same. I got a little squiggly there. Let me fix that one. Okay. Let's minimize this a little bit. It stays on there. Oh, doesn't minimize it. There we go. And then the last two here. Anything below gets reflected. Anything above stays the same. So just basically trace over. On a test, if we ask you to do this and you don't trace over those invariant points, you get it wrong. Okay? I need to see your pencil, and if I can't see your pencil, even if you say you used pencil, then you need to get a darker pencil. Okay? You have to graph the reciprocal. The absolute value. So if you don't actually use your pencil, then you're telling me it's not part of your graph. Do I what? If we ask you, but you don't have to. My smart board's a little off on its alignment. Close. Okay, so then what happens here, so choose some nice points. And this is where maybe I'll expand out because it's a little bit easier for me. Okay, so yeah, I'm going to go back and fix these because now that I've expanded, see, I wasn't exact. So here, and just so you know, this actual graph here is the graph of a trig function, okay, tangent function. So then here, so where's some nice values? There aren't that many at grid crossings, right? So really none, but choose a nice y value. So for example, there's we'll do y equals -1. So it's a little bit to the right of -4. So now that's going to be up there, +1. Then -2 for that particular x value now becomes +2. And then -3 for that particular x value becomes +3, so that you can see what they look like. So again, this is curving down this way, so when you reflect that, it's going to be curving up this way. Okay, so it's not really going to be an actual curve there, but that's good enough, close enough. So again, here -1 becomes +1. -2 becomes +2. -3, if you look at it straight on, becomes +3. What happens in these graphs is they have asymptotes. So really, you don't know a lot about, you haven't done a lot of any trig graphing, but really there's an asymptote there. And then there's an asymptote here. And then there's an asymptote here. So this, because it's approaching that asymptote down here, it's going to approach it up here. So this is going, sorry. So this is going to approach it up here. That was a little bit off. Again, my smartboard is off. So then -1 becomes +1, -2 becomes +2, -3 becomes +3. Okay. So there's a bunch of U shapes. Yep.
On the test, did you have to draw the asymptote?
No, not for these ones, but you do for the reciprocal ones, yeah. And then the last one here. So parts that stay the same are anything that's above the x-axis or on the x-axis. Okay, and then these will be reflected up. So just try your best. So try to look for the minimum. So the minimum is kind of about -5.6 or 7. And the x is a little bit to the left of 4. So then go +5.6 or 7 there. Okay, so it's going to be steeper here than here, right? So this kind of, really what happens in this kind of graph is we have a point of inflection. You'll talk more about this in calculus, where it changes from concave down to concave up. So kind of around there at -3. So that would be +3. Okay, so then, so this will be kind of like this, down like that. And then this one, the lowest value is -5.7 again, for this x value to the right of -2. So +5.7. Then choose another point maybe, so -3 becomes +3. And then that point of inflection is sort of around here. And that's at -3, so it becomes +3. Look something. Like that. Okay. So that's where we'll end it for today.